Insects, some of Earth's most ancient inhabitants, are far more complex than we often give them credit for. Beneath their tiny forms and simplistic appearance lies a sophisticated communication system, one that humans are only beginning to decode. In this video, we will dive deep into the fascinating and often surprising ways insects communicate, showcasing unique and little-known facts about their secret language. By the end, you'll have a newfound respect for these small but mighty creatures. Secret 1. The basics of insect communication. Insects rely on a variety of modes to send and receive signals. These include visual cues, chemical signals, tactile interactions, and even sound. Each mode of communication is adapted to the insect's habitat, physiology, and social structure. While humans predominantly use verbal and written language, insects employ mechanisms far beyond our comprehension, optimized for survival and reproduction. Chemical communication pheromones. Many insects, like ants and bees, use chemical compounds known as pheromones. These substances can signal danger, guide members to food sources, or attract mates. For instance, ant trails. Ants lay pheromone trails to guide their colony to a food source. What's astonishing is that the trail's strength diminishes over time unless reinforced, allowing the colony to adjust to new priorities dynamically. Bee alarm pheromones. When a bee stings an intruder, it releases an alarm pheromone, alerting other bees to attack. Sound communication. Crickets and cicadas are well known for their chirping and buzzing, but did you know that some moths can emit ultrasonic clicks to confuse but echolocation? This is a prime example of acoustic mimicry, a lesser-known phenomenon in insect communication. Visual signals. Fireflies are famous for their bioluminescent flashes, but did you know each species has its unique flashing pattern? This ensures that males and females of the same species can find each other amidst thousands of other flashing lights in the dark. Secret 2. Unusual and rare communication strategies. Vibrational signaling. Some insects, like leafhoppers, communicate through substrate vibrations, sending signals through plant stems or leaves. These vibrations are often imperceptible to human ears, but are crucial in courtship and territorial disputes. Chemical camouflage and deception. Certain caterpillars mimic the pheromones of ants to gain access to their nests. Once inside, they either feed on the ants or their resources. This kind of deceptive communication is a form of evolutionary trickery. Social hierarchy communication in termites. In termite colonies, chemical signals help maintain the strict hierarchy. For instance, the queen termite emits specific pheromones to suppress the reproductive abilities of worker termites, ensuring she remains the sole egg layer. Secret 3. Cross-species communication. Butterflies and ants. Some species of butterflies, like the Lichenidae, have evolved a symbiotic relationship with ants. These caterpillars secrete a sugary substance that ants love, and in return, the ants protect the caterpillars from predators. Communication between the two species involves both chemical and tactile cues. Mimicry in orchids and pollinators. Orchids are masters of deception. Certain species mimic the appearance and pheromones of female insects, tricking male pollinators into attempting to mate with them. This ensures pollination, but leaves the unsuspecting insect empty-handed. Secret 4. Advanced social insect communication. The honeybee dance. The waggle dance of honeybees is one of the most sophisticated forms of nonverbal communication in the insect world. By moving in specific patterns, a bee can inform its hive mates about the direction, distance, and quality of a food source. Recent studies suggest this dance is influenced by the Earth's magnetic field, a detail rarely explored in popular discussions. Army ants and collective decision-making. Army ants use a combination of pheromones and tactile signals to coordinate massive hunting raids. Their communication ensures that millions of ants move as one cohesive unit, creating a living network capable of overwhelming prey much larger than themselves. Secret 5. Implications for humans and science. Understanding insect communication has profound implications. Agriculture. Studying pheromones can lead to environmentally friendly pest control methods. For instance, pheromone traps can disrupt mating cycles without harmful chemicals. Technology, biomimicry inspired by insect communication, is leading to advancements in swarm robotics, where robots mimic the collective behavior of ants or bees. Ecology. Decoding insect communication helps us understand ecosystems better, as insects play key roles in pollination, decomposition, and the food web. At the end, insects may not speak as humans do, but their communication is no less intricate or meaningful. From pheromones to vibrations, bioluminescence to mimicry, their methods are a testament to the wonders of evolution. By studying and respecting these tiny creatures, we unlock secrets about the natural world and even ourselves. So the next time you see a bee dancing, an ant following a trail, or a firefly lighting up the night, remember, they are speaking in a language as old as time, one that continues to amaze and inspire. If you're interested in discovering more about wildlife, don't forget to subscribe to the channel and activate the bell to receive all the latest updates.